So Nautilus was started in 2016 up there in the Bay Area. And at that point, really big, deep tech startups were first given a chance, specifically driven by the tailwinds of folks like Tesla and SpaceX. So for the first time ever, venture capitalists started to believe that you can create these really large, how we call economies of scale with places like automation and automotive industries, and of course, aviation was next. So when we started the company, we had a really big aha moment, specifically surrounding logistics space. Of course, there's only two ways to ship goods internationally. The first one is by ocean, which is very slow, but very much a commodity. And of course, the second way is by air freight, which is very timely, but brutally expensive. So that coupled with a huge focus on sustainability and a big realization that e-commerce is going to be driving essentially the next generation of logistics for the next 20 to 30 years, really created an opportunity and opening for a new entrant to enter the space. And the third key piece of the technology is autonomy. So the first airplane flight was actually 1903. The first autopilot in an airplane was 1913. So we actually had aviation or autonomy technology for over 100 years. But for the first time ever in 2013, the FAA opened up what we call a next generation of regulations to allow autonomy into the national airspace system. So with those kind of three key insights, Nautilus was born. We switched away from a traditional tube and wing configuration to something called the blended wing body design. It was stumbled upon by NASA and Boeing in the late 1990s. For a variety of reasons, it makes for a very bad passenger airplane, but for a freighter, it makes sense. So kind of taking the huge leap forward that it's really commerce that's driving air freight today, traditional tube and wing airplanes are cubing out on volume before they top out on weight. And so what the industry was looking for is a more volume-centric design. So for the same weight and size of airplane, the blended wing body can introduce almost time and a half more capacity. And so now traditional airplanes or Nautilus airplanes are not cubing out on volume before they top out on weight. What that means to our airline customers, we carry double the amount of revenue cargo for the same trip. When you couple that with blended wing body aerodynamic technology, we're actually able to reduce fuel burns by 50%. So not only can we carry more revenue cargo for the same trip, but we can also reduce the fuel burn and create a more sustainable way forward. And then lastly, sustainable aviation fuel. So there's a huge push within the industry to decarbonize by 2030 within certain aviation airlines, and of course by 2050 for the majority of them. And so when you couple SAF and blended wing bodies together, we're able to reduce emissions by 80%. And of course, the last piece of the puzzle is the autonomy. Using the next generation of drone-level regulations here in the United States, we can actually scale our airline customers, allowing one remote operator to operate 3 airplanes at the same time. So when you think about how you actually get there, we kind of took the Elon Musk approach for SpaceX, and so we have a stair-step approach to get to the larger products. So Nautilus is actually a family of 3 airplanes. The first one is the Kona regional freighter. That'll be 1 to 2 hour flights carrying about 4 metric tons of payload cargo, but it can go up to emissions of 900 nautical miles. A lot of our customers use this to connect smaller regional airports to larger hubs. A good example might be the mainland Japanese island to the lower supply chain. We have a lot of Canadian customers connecting indigenous communities up north to the larger, more populated areas down south. The second one is the Alisio. That'll be a Boeing 767 replacement. That'll be North America, transatlantic, Europe, and Asia. And then the flagship product is the North. That'll be your long-haul freighter, essentially connecting any 2 points on Earth. That's the biggest market for a lot of our customers, essentially Asia to anywhere. What's really unique about our airplanes as well is traditional tube and wing configurations are really centered around passengers. There's an upper and a lower deck. With Nautilus airplanes, we have a single deck layout, allowing us to maximize volume. And so not only is the airplane unique in shape, but the cargo bay section is actually clocked to allow even more revenue cargo to be entered into the space. But things like perishables, pharmaceuticals, of course, standard air freight pallets for e-commerce, of course, outsized machinery and Porsches for our investors all nicely fit into this cargo bay section. We do believe that there is a breakthrough in technology for hydrogen. We still are about 15 to 20 years away. There's challenges surrounding the production of hydrogen, being electrolysis is too expensive, the infrastructure required for it, and also the engine propulsion technology. But we do believe that it's finally on the horizon. We're partnering with a company called ZeroAvia, which is the front leaders in aviation hydrogen technology, specifically the propulsion side of it, to start looking at integrating new hydrogen ideas into the cargo sector. And of course, one of the challenges that they're having is hydrogen is very volume-centric. Whether it be on the gaseous side or the liquid side, you still need a lot of volume. And so when you actually inject it into a traditional tube and wing configuration, you're actually you need to reduce the payload by about 40%. When you move it into a more volume-centric design, such as the blended wing body, you have 0 reduction in mission payload or revenue cargo. We spend quite a bit of time with our future customers at their world ports, as I would say. This is a turnkey solution to their existing network. So existing ground support equipment, existing engine technology to start out with, as well as existing apron spaces, meaning the size of the airplane and the parking spot, which is very important to them. When you think about the total addressable market for ideas such as this is definitely a 0 to 1. The new freighter market alone is a $270 billion market that is a duopoly between Boeing and Airbus and now Nautilus. We're the only entrant into the space with a purpose-built solution for cargo freight, and we actually see with the price points that we're able to offer to our future customers, the airlines, we're actually able to grow this market to $470 billion. So even though we're a young Series A company with very large ambitions, we've been able to find quite a bit of traction. Our order book today sits at $8.6 billion from major airlines all across the globe, and over 470 plus aircraft split across the 3 products within our family. So some of our customers are Flexport, which is one of the darlings of San Francisco, the largest digital freight forwarder, is a customer and an investor into the company. Ameriflight, the largest operator for feeder operations here in the United States for FedEx and UPS. Astral Aviation's largest all-cargo carrier out of Africa are some of the customers I've been able to announce, but there's many, many more, and you'd be surprised at the names. The company has also started to take in meaningful revenue in the form of customer deposits. So imagine purchasing a Tesla, you secure a couple $1,000s down to secure a position in the manufacturing queue. We do this on a grandiose level. Typically, our production costs, depending on the airplane, cost between $500,000 and $1 million. One of the other things that's very interesting, especially being here out of San Diego, is dual-use opportunities. So not only are products meant for the commercial sector first, but they're finding quite a bit of traction with the DoD. Specifically, there's 2 large contracts on the horizon with the Department of Defense, United States Air Force. The first one is the next generation of tanker. And so NGAS is what it's called. It's a $40 billion opportunity. So we're working with the United States Air Force on influencing the requirements for that sector. And then also the next one is the next generation strategic airlift shortly after. And all 3 products of the Nautilus family fit nicely within that umbrella. So obviously big vision, but where do we start? It's the Kona. So Nautilus today is based out of 2 facilities here in San Diego. We have an office downtown, which we recently just moved out, which is where the majority of engineering sits. We also have a production facility at Brown Field, which is really close to the Tijuana border. So I'm going to see if I can play this video, if it'll help, and I'll kind of narrate through it. So a lot of people believe that you can't accomplish a lot with very little money, so we're going to try to prove that wrong. One of the challenges within the blended wing body configuration is specifically the inherent instability of the design. And so Nautilus did a wind tunnel test right here in San Diego, which is one of the world's premier facilities for actually wind tunnel testing, back in 2019. We found out a lot of challenges technologically wise with the stability and control of the airplane. We took it back, spent about a year and a half running computational fluid dynamics, and finally finished the second wind tunnel test configuration about a couple of years ago. And that solidified all the stability and control. So this airplane is actually inherently stable all across all 3 axes, which makes it certifiable. We have software in the loop simulation validating it. You can actually fly it in a big simulator here at our Brown Field facility. All the CAD is pretty much complete. We're turning out key packages for folks like Pratt & Whitney Canada, Collins for the cargo loading system, and Janicki as well for the carbon fiber. We started to build mock-ups as well for our future customers, which gets them excited, talking about the height, the width, and things like how you position the cargo containers within the cargo bay section for our larger products. And then in April of this past year, we validated with a scaled prototype flight that this airplane is inherently stable across 3 axes, which creates a huge differentiating factor across the competitors. Here you see the co-founder actually building the vertical tails. Vertical tails, ailerons, and control surfaces already finished in our facility, and we're actually working on the wing and the carbon fiber structure next. So we are about 24 months away from first flight here in San Diego. Working with a direct Ameriflight customer, a launch partner, we've developed a pilot operating desk called the Pod, and we already have hardware in the loop simulation going in our hangar as well for fly-by-wire flight controls. That's it. Thank you so much for your time this morning.